is CORDIScovery. Hello and welcome to this episode of CORDIScovery with me, Abigail Acton. It's December, and many of us are about to put our feet up and think of seasonal holidays. And since we're on the subject of celebration, let's celebrate women in science. Our three female researchers, whose work has been supported by EU science funding, come from very different fields. Here to share their work and their ideas on how to make careers in research more accessible to other women are Elena Ghezzo, a fellow of Foscari University of Venice in the Department of Environmental Science, Informatics and Statistics. Elena is particularly interested in screening fossils using spectral imaging and in the distribution and extinction patterns of large carnivores before the Holocene. Hi, Elena.
Hi, everybody.
Camilla Pierella is currently an assistant professor in the Department of Informatics, Bioengineering, Robotics and Systems Engineering at the University of Genova. Her main research activities are related to neural control of movement, robotics for rehabilitation, and body-machine interfaces. Hello, Camilla.
Hello, Abigail.
Erika Hausenblas is Professor of Applied Mathematics at the University of Leoben in Austria. She studies how stochastic systems characterized by randomness and uncertainty impact the modeling of a wide range of phenomena such as weather patterns, stock markets, and biological systems. Welcome, Erika.
Hello, nice to meet you.
And you as well. I'm going to turn to Elena first. The ReFind project uses cutting-edge software and multispectral sensors mounted on drones and satellites to identify likely fossil sites and to prevent the destruction of undiscovered fossil heritage by humans and by climate change. Elena, can you break down what I've just outlined? So what new tools and methods is the ReFind project bringing to the table to further our discovery and protection of fossils?
So basically the idea is that because there is a lot of innovation about fossils and how to study fossils in many ways, but there is no innovation regarding how to find new fossils on land. My idea was to take satellite imageries, the imageries that we can use to see land and cities and streets and everything that is exposed on the surface. The idea was to apply the same methodology to find the actual fossils that are exposed the same way in desertic area, like in Arizona or in Egypt or in places that are far away, so difficult to reach, difficult to organize expedition to go there and collect the fossils. And once you find fossils there in person, it's difficult to manage how to transport, how to move the fossil from the ground to the museum where you can study them. So the idea was to collect the fossils and the information from the ground before to go there, before to organize everything. So I use the properties, the optical properties of fossils. What does it mean? It means that I took the imageries, and from the imageries I can detect something that we call the spectral signature. So it's basically the difference between the fossil and the ground. And in this way, we can map the surface and have an idea of what we should expect once we will reach places that are very, very far from our lab.
It's fascinating, isn't it? Because not only are these places inaccessible, but also it gives you a clear idea of whether it's worth launching an expedition to go out there in the first place, and also the topographical constraints with regards, as you say, to shipping the specimen back as well. Very, very interesting. It's one of these wonderful ideas which, when you say it, seems enormously logical, and one wonders why it wasn't done before. Have you any idea why this hasn't been done before? All these wonderful images of the Earth's surface, and why not look for fossils that way?
We didn't have the technology. So the resolution, the high resolution we needed to detect the fossils that, they are big, they are 10 meters long, but they are just 10 meters long. It was not available before 2014. Nowadays, we have at least 2 satellites able to recording imageries that reach 50 more or less 50 centimeters in spatial resolution, and reach, of course, in the multispectral region, we reach 2 meters of resolution, which is great, and enable us basically to catch the fossils on the ground.
Oh, I think it's absolutely wonderful. And has this actually been put into effect? Have you used this now in the field?
I use it. We try to map the distribution of fossils in Arizona at the Petrified Forest, which is a national park. And that means that we cannot walk freely on the ground to detect each of the pieces that are exposed. And so we tried the potential of this method using that national monument. And we are able to detect up to 90% of the fossil exposed under the surface where we test the method. Yes.
Oh, that's very thorough. That's an excellent result. Fantastic. That's super. Why did you get involved in this field?
So I always love to match different field of expertise. So I started as a paleontologist and I was interested on GIS.
What's GIS, Elena?
Geographic information. So everything that goes from map to your GPS, your phone, and location with coordinates goes under the name of GIS, basically, georeferenced information systems. So I basically matched the two expertise I developed during my first years of my career. And so this idea just popped up in my brain, and I decided to pursue it and to try the potential of it.
Oh, that sounds absolutely brilliant.
Basically, I'm going back from satellite to Earth, and I'm using the optical properties and this multispectral and hyperspectral method to detect fossils that we already have in museums, to detect their preservation, to monitor their preservation, to be able to recognize materials that have been added to the fossils, and we know nothing about those. So possibly the heritage can be double checked.
Oh, I see.
The way we restore and we maintain the collection today is very, very different from a few decades ago. So it's important to keep trace of it. And for example, to recognize fake fossils that are quite important, because if you have a fake fossil, is a fake species, and make misunderstanding and errors in the description of evolution. So it's very, very important to be sure that the fossil you are dealing with is original and was collected properly.
And is authentic.
Yeah, absolutely.
Well, thank you very much, Elena. That's fascinating work. Thanks for explaining that. And we're going to hear more from you a little bit later when we have our general discussion. But I'm going to turn to Camilla now. Camilla, the REMAP project created a novel approach to the neuromotor rehabilitation of patients with multiple sclerosis, MS, involving body-machine interfaces known as BOMIs. What are the current go-to therapies for patients with MS, please, Camilla?
So currently, one innovative approach for rehabilitation in multiple sclerosis can be, apart from the classical physical therapies, can be using robots, exoskeletons for upper limb or for lower limb to help regaining some mobility for walking or for doing any kind of daily activities. What is novel of this approach was that instead of using bulky robots and very expensive technologies, we wanted to use very low-cost sensors that you can put on the body parts that you want to rehabilitate. In my case, I was focusing on the upper limb. And you can do some exercises without the burden of having a robot or of having extra weight on your arms. And you can also record not only movement, but also muscle activations and things like this. So you can have a very deep information on the residual mobility of these people and how they change through the disease. Because unfortunately, multiple sclerosis is a daily changing disease, unfortunately.
Right. I understand from what you've told me before about this project is that you're able also to measure the impact of training, physiotherapy training, and so on. You mentioned something about the identification and characterization of biomarkers of motor impairment at different levels of the nervous system. So what exactly were you talking about when you were thinking about that? What do you mean by the biomarkers and the characterization?
Yeah, with biomarkers, I mean some specific features that you can extract from like different signals that you can record from the body. And like with different level, I mean that I can go from the central nervous system. Indeed, we were doing MRI, which is magnetic resonance imaging. And with that, we could acquire and measure the structural and functional changes that can occur in the brain before and after the rehabilitation training. And so like from the brain scan, we could assess the changes in the, more than in the structural, in the functional link that you can have between different brain regions. And then we like move more in the periphery. So like we measure like some changes that you can have in the spinal cord, because we were doing MRI scan also in the cervical region of the spine. And then measuring also the kinematics, so we could assess changes and hopefully improvement in the movement, for example, of the arm. And what we wanted to investigate more in detail was also the proprioception. I don't know, like proprioception is the sense that we have of our body in space. Now, without looking my hand, I can immediately tell you where my hand is. And so what we found, like our preliminary results were very encouraging. And we found that with the motor training, you have motor improvement, but you also have improvement in proprioceptions, because we were running tests to assess these proprioceptive skills in people with multiple sclerosis.
Okay, and this is all down to this new way of using the BOMIs that are helping people to rehabilitate.
Exactly, because the training with the BOMI at the beginning, it's not very intuitive, because we are, let's say, transforming in a not usual way the movement of your body in the control of a cursor on the screen that allow you to play video games. Okay, we are not doing a transformation, let's say, one-to-one. But we give the subject some freedom that push him to explore various movements and various combination of movements that actually make the people more conscious about his motor abilities and about actually the positioning of his body in space. So that's why I'm saying we are not only training motor, but also proprioception.
Excellent. You must be really, really thrilled with your results, because the project is really showing positive results, isn't it?
Yes.
Excellent. That's fantastic. Are you noticing that other rehabilitation centers, other people who are specialized in rehabilitation are interested in these exercises and this training that you have developed?
Yes. This study started in Genova, in the hospital. It's currently ongoing because we managed to find some extra fundings after the end of the Marie Curie, so that the project is still ongoing. And we see that its potential and its long success, hopefully.
Yeah. Excellent. That's really good. Thank you very much. That's very, very interesting. Thank you. I'm going to turn to Erica now. Erica, chemotaxis is the orientated movement of cells in response to a chemical gradient. Now, the STOPAT project was curious to see what happens when this is perturbed by a random external factor termed stochastic noise. Now, doing so means modelers can characterize dynamic behavior more accurately. So for the non-mathematicians listening in, and I count myself as one of those, can you explain what stochastic partial differential equations are, please, Erica?
Okay, usually you want to describe the nature, like fluid or biochemical systems and these things. So you describe by kind of equations, normally partial differential equation or differential equation, where you bring into relationship the state of the system and the short time, the derivative up to the time, that means the short time changing of the system, how it's changed in a short time. These are, you call differential equations. And what I'm looking for is if you put then some randomness into the system, what is changing? Can you describe or pop there up some certain phenomena which does not exist in this deterministic case? Is there a difference? And if yes, that's fine. And secondly, how to model these kind of stochastic system numerically? usually you do not have really analytic tools to model them or say something. So you need numerical modeling to see what is happening to the system, in which direction it moves, and to see what's happening.
Sure. Okay. Can you? That's fine. That's excellent. Could you give us an example of a particular system that lends itself to this type of modeling and examination?
Okay. A typical example of chemotaxis is slime mold. This is a really nice example. So a slime mold, if there is not sufficiently much food there, it produces a chemical substance that attracts the other cell or the other slime mold cells. So the slime mold aggregates and form a kind of tower with a big peak. In this way, if there is some wind, it often takes the top of the peak and they come to another place where it could be a nicer environment and they find some food again.
So what we have is a group of cells that when they have insufficient food will go higher and higher, group together and call more cells together, and they'll go higher and higher so that the top part can get blown away to somewhere that might actually provide more food. I mean, that in itself is a small miracle. I don't know about you guys, but I think that in itself is a small miracle. So that's an example of chemotaxis, as you said. So Erica, what you are interested in, I think, is the inherent randomness of that, yes?
This comes if you derive from a biological system, the mathematical equation, it's based on the central limit law. And you kick out taking the limit of all cells which are going to infinity, all the randomness or all these fluctuations which normally happen. So usually one has a deterministic equation. That means if you know the starting point, you know the end point. That's it. But this kind of determinism in nature or in life, all the time something is happening you haven't foreseen, or even the molecules, or the slime cells do not go really the same way how it's described mathematically. So I put back into the system the randomness, and the interesting point is you have new phenomena, new things are happening, and that's a quite interesting issue.
Yes, absolutely. And also it makes it much more realistic because, I mean, life is full of a degree of random things. I was going to say random chaos, but I know chaos actually has a specific meaning in this area, so I'll stick with the word random. Has a whole load of random factors that do kick in. Yeah. Okay, that's great. Erica, what got you involved in this field of mathematics? Because after all, it's very biological. Your application is to other areas like biology, for example, but also I would imagine climate and weather patterns and all sorts of things. So what got you involved in this area?
Okay, I'm a mathematician, but I like application of math in biology or chemistry and also physics. And in this way, first, I have the feeling my research is useful. So I'm not really in a golden tower thinking about my own things. And the next is often you have really interesting systems, but the people in biology and so they often try to model it or write down the equation, but they do not really reflect about it. And often they do not have really a rigorous proof.
Okay. So you feel that from a mathematical perspective, you can provide that rigor?
Yes. I can really investigate, then maybe design or think of algorithm, how you can really model it numerically such that what you get after them on the computer and what you see that this is really the equation or models the equation, and how quick is the convergent and these things. So yes.
Yeah, so basically your equations and your modeling are actually reflecting more what you see as a result of the phenomenon itself. Mm-hmm. That's excellent. Thank you very much. Well, as I mentioned, very, very different domains, but one thing you all have in common, and me as well, is that we're all women. And so I want to talk now in a slightly different vein from our normal CORDIscovery podcasts. I want to bring you together to talk a little bit about how we can make the career of a scientific researcher more accessible to women in general. So I'm going to ask you a question, and then I'd like to call on you one by one to answer. And I think that one of the things that perhaps would be really interesting to know would be, if you could talk to your 18-year-old self, what advice would you give her? And Elena, I'm going to come to you first for an answer. What would you say to yourself at 18, knowing what you know now?
Oh, I have a lot to say to her, but the priority, I think, it's to search for a good mentor or someone who can really understand your perspective and your wishes, and someone who has experience in the field you want to approach in a way that can suggest you the good way, the good match for you to deal with, to pursue it, and to reach your goals, basically.
Yeah, that's a very nice idea. A mentor, I think, is very important. My other guests, Camilla, Erica, did you have any good mentors at the beginning of your scientific career? Anybody that you could talk to and trust? Camilla?
Yes, I feel very lucky because in every step of my career, I was receiving like good suggestions from my mentor, and independently, like from the sex, I had mostly male mentors, and now I have a female mentor, but they all gave me very, very precious suggestions and indication.
Mm-hmm.
And one thing that I found like very, very helpful was that they always gave me freedom and always, made me do my choice.
They didn't try and constrain you. Yeah.
No.
And in fact, Camilla, what would you say to yourself at 18?
That's a difficult question. But the very first thing that it's coming to my mind is that I would tell her to be less shy and more brave in making, decisions that bring you on the other side of the globe. But despite of that, I also tell her that good job. So good job that you did it. So
yeah, that's good. Erica, what would you say to your 18-year-old self?
Okay. I say there is no free lunch. That means you have to work for it and to get it, and you should not hope that anybody picks you up and so on. So, for example, I really, my first project is after my PhD, I wrote it and I submitted it because I was not really successful in application. So I just took it in my hands and wrote a project and got a scholarship. That was my beginning.
There you go. So not being put off by initial perhaps blockage, but keeping pushing. And my next question to you three of you, again, one by one, is, as a woman working in science, what would be the one thing that you would change to make the profession more accessible to other women? So, Eleanor, I'm going to start again with you. What would be the one thing that would make it more accessible for other women, do you think?
Let's say that I am on the side of men. So pushing to be a good father or a good husband is the best way to introduce or to make women free to feel themselves in science. So one of the things I always put on the table is it should be mandatory for fathers to have paternal leave after the baby is born, because a father is as important as a mother right after the baby is born. So why to make a difference? Of course, we have different rules inside the house. We provide milk, they cannot, but nowadays they also can buy milk basically and do everything they can to to have a good match with the baby, which is very important also when the child grow up, basically, to have a good example in the house.
Yeah, absolutely. That's what men can do to help to ensure that women can lead fulfilling careers. And what about mutual support that other women can give each other?
So for example, when I came back from the US, I found a very welcoming environment with the other women, my colleagues, doing the same experience I was doing, the same problem, the same issues related to a lot of change, of move in and out from one country to another, from one university to the other. So that was very, very important. And the second thing is very important to make women feeling safe in the field of science and supported by the environment itself, is to not looking at your colleagues or like competitors, but look at the other women as a supporter, because we have exactly the same problems.
Camilla, I know that you've also been to the US, haven't you? What was the difference? Did you notice any difference in culture between the pursuit of a scientific career on either side of the Atlantic? How did that go, Camilla?
Like Elena said before, I had the same experience as her. When I came back from the US to Europe, I got like a lot of support from my colleagues. And imagine that in my lab, the one where I'm now and the one where I was in Switzerland, there were like many women like me. So I cannot say anything like bad. I always found support from other women, and I really believe, like Elena said before, that this is like the most important thing, to see in your colleague like a friend, not an enemy.
Yeah, or a competitor. No, indeed, absolutely. Yeah. And Erica? What did you find with regards to cultural attitudes regarding women in mathematics? Are you seeing anything?
First, I have the impression that really in math, there are less women than in biology and these things. Secondly, if I come to Italy to conference, there are much more women than in Austria or Germany or even UK. There are less women, and I once even was in UK at Edinburgh at a conference. They were 2 women out of 40. And I see it also where I'm teaching. I have a course, for example, in mechanical engineers. There are 35 and 1 woman. And I would say, for example, when I got my professorship, many did not really congratulate it. The first reaction was, oh, what are you doing with the children? It will be complicated and so on. And then I stopped telling it or saying, oh, I got a professorship, just because it's and maybe also something, if I got then divorced and were applying for a position, I just nobody told about that I'm a single mother, because I was sure I will not get any position in this kind of
right
in Austria or something.
Whereas a divorced father might not have to keep quiet about that. Very interesting. Thank you, Erica. Rather, that's very interesting indeed. And congratulations on your professorship. We all of us congratulate you sincerely. That's a huge thing. Okay, wonderful. And I'd just like to ask you a final question here. It's a classic one, I'm afraid, almost cliched. I'd like to just think a little bit about work-life balance commitments, because it's obviously something that is a challenge for all of us. So how could that be helped, do you think? Erica, I'll turn to you first. What could be done to make the life of a female scientific researcher easier with regards to work-life commitments, balancing those?
Yeah, I think first for children like kindergarten and these things, that this is easier. And I do not know if many things were from my colleagues, but I guess it's a whole society where you have to fight against it. It's not only the university.
Fight against what, Erica?
I think it's a lot of small things. For example, I wanted to put in the tax money for my babysitter, and which is possible if a babysitter is necessary. And the tax officer kicked out this of my tax declaration. Since it's not necessary, I could have taken another less demanding job. Or, for example, to give my daughter in the school, which would be more comfortable with my mother and the organization, I had to fight each year. They are small things mostly.
Yeah, no, it's not that small, and it also gets tiring every time to have to keep doing it. Indeed, yeah. Elena, what would you think about work-life balance? How could that be improved?
If I can say, it's a mess. So to improve the work-life balance is to give more flexibility to women to manage the private life. So, for example, I'm very productive at home, and it doesn't mean I'm working less. I'm actually working more efficiently. And because I'm trying to do something at home too, like washing machine, lets the washing machine goes, takes only 5 minutes. It's like a coffee break, an Italian coffee break, let's say. And so it increases the effectiveness of my work, my daily work. Also, of course, improve the services available for women to manage children's, like the daycare and everything. So, for example, in Italy, daycare is open until 4 p.m. That doesn't make sense because nobody finished work at 4 p.m. We have to work until 6 p.m. at least. And if you don't have a babysitter or a grandma or a grandfather picking up the baby, you have to leave work earlier than your colleagues that are usually male. And that means they can go ahead and work for additional 2 hours per day. At the end of the month is a huge difference. And this is just an example. And of course, you have to have support in your house with your husband, be organized. But it's not always the case. And there is no balance between the effort you put together in the family. And it's a fact. We cannot say, okay, we can divide it in 50%. It's never the case.
Camilla, do you have any observations with regards to work-life balance?
Well, I think that there is one keyword that Erika and Elena already said, which is support, that unfortunately sometimes is missing. Support from like your partner, if you have one. Me, I don't have like children right now, so I cannot understand this. I mean, I can try to understand, but I'm not living the same problem as Elena and Erika. But I'm sure that like having the good support from your partner might definitely help, and from the institution, of course. I think that COVID taught us that smart working can be an option and should be an option because if you want to work from home, you don't have a job that it requires you to do operations in your workplace, then you should be allowed to stay home, so that in that way, like, you can improve the work-life balance and not be, 80% of your time at work and 20 at home.
Excellent points all of you are making. Thank you very much. So to wind up, does anybody have one piece of advice that they think that they would give to family members, perhaps partners, at this time when Christmas often puts an awful lot of pressure on women? Yes, Elena.
Yeah, I have an idea actually, because we talk a lot about how to work together with our partner, and the important to make women feeling less stressed and make them laugh. And I always see how women kind of increase the serenity, the happiness in the house, in any house, when they laugh a lot. And I love that feeling. So I want to put down a challenge for all the men listening, because it's close to Christmas time and we are all busy running from one place to another. It might be funny, let's say funny, to create situation where your partner, your mom, your friend, your sister, or just a stranger you see every day going to work or places, just to put down ideas to make that person happier or less stressed in a situation where created just for that person. It shouldn't be something very difficult to make or something very expensive. A situation or a little present can be enough to make the woman feeling important, feeling satisfied, or feeling just, okay, you are noticing her effort to make everyone else happy.
Make women laugh. I think that's an excellent idea. Well, listen, I want to thank you very much for sharing your time with me today. We've had some interesting discussions both about your own personal careers and about widening a scientific career out to other women as well. So if there are young women listening to this, there are some useful pointers for you here and some inspirational guests. Thank you very much for your time.
Thank you, Abigail.
Thank you very much.
Thanks a lot.
Bye.
Bye-bye.
You're very welcome. Goodbye, everyone. Bye-bye. If you've enjoyed this podcast and are interested in the latest scientific research coming out of the EU, have a listen to previous episodes. Follow us on Spotify and Apple Podcasts, and check out the podcast homepage on the Cordis website. We've talked about living archives of viruses and innovations to forensic science. In our last 31 episodes, there will be something there to tweak your curiosity. Perhaps you're interested in seeing what other EU-funded projects are doing in these areas. The Cordis website will give you an insight into the results of projects funded by Horizon 2020 and Horizon Europe. The website has articles and interviews that explore the results of research being conducted in a very broad range of domains and subjects, from sea lung jellyfish to computer phishing. There is something there for you. Maybe you're involved in a project or would like to apply for funding. Take a look at what others are doing in your domain. So come and check the research that's revealing what makes our world tick. We're always happy to hear from you. Drop us a line, editorial@cordis.europa.eu. Until next time.